So this is JEST Physics 2024 Electromagnetic Theory Part A MCQ 1 marks question. So in this question, it is given that a solid sphere of radius r has a volume charge density rho is rho naught sine 2 theta. And we have to see how does the leading term in the electrostatic potential depend on the distance r far away from the charged sphere. So we have to find the approximate dependence. So we will use the multipole expansion method. So here we have a sphere of radius r and its charge density rho is rho naught sine of 2 theta. This is given, and point P we have where we have to find the potential. This is r far away from the charge distribution, so r is far greater than r. Now according to multipole expansion, so let's see what will be the formula for multipole expansion. So according to multipole expansion, this potential VR is given by 1 by 4 pi epsilon naught. Now first dependence is 1 by r. We call this as monopole term, and this integral is rho r dash d tau dash, where dash represents the position of source charge and this r represents the position of field. So, and second term is given by dependence is 1 by r square, and the second term is r dash cos theta dash rho r dash d tau dash. Similarly, you have a third term also, that dependence is 1 by r cube, and so on. Now, if we have to see the approximate dependence, so we have to calculate these integral, monopole term and dipole term. So let us first see what will be this integral. Rho r dash d tau dash. So since it's a volume integral in 3 dimensions, so it's a triple integral. Rho is given as rho naught sine of 2 theta dash, again dash for source charge, and d tau is given by r dash square sine theta dash dr dash d theta dash and d phi dash, where r dash varies from 0 to capital R, theta dash 0 to pi, and phi dash 0 to 2 pi. So if we calculate this integral, rho naught is constant, r dash square, this integral will give you r cube by 3, d phi will give you 2 pi. Now with respect to theta, this integral is given by, if we write sine 2 theta is 2 sine theta cos theta, so this is 2 sine square theta dash cos theta dash d theta dash 0 to pi. And we can easily check that this integral will be 0. So first term will be 0. So now we have to check for the second term. So second term is again volume integral, r dash cos theta dash, then you have rho r dash d tau dash. So this will be triple integral. Let's write r dash cos theta dash. Now this is rho naught sine of 2 theta dash into r dash square sine theta dash dr dash d theta dash and d phi dash. Again limit will be 0 to r, theta dash is 0 to pi, and phi dash is 0 to 2 pi. So if we see this integral, now rho naught is again constant. Now this will be r dash cube, so that will give you r power 4 by 4. d5 integral will give you 2 pi. And if we see integral with respect to theta dash, so if we write sine 2 theta is 2 sine theta cos theta. So that will give you 2 sine square theta dash cos theta dash d theta dash. And this we can write as rho naught r power 4 by 4 into pi 0 to pi. Now this 2 we can multiply here, and let's write it as this will be 4 times 2 sine theta. This is 2 sine theta theta dash cos theta dash whole square d theta dash. So if you expand, that will give you 4 times sine square theta dash cos square theta dash. So that will be given by rho naught r power 4 by 4 into pi 0 to pi, and this is sine 2 theta dash whole square d theta dash. And you can easily check this integral will be non-zero. So if we have to see the main dependence, so main dependence is leading order term is 1 by r square. So we can easily say V is main dependence term is 1 by r square. So option C is correct. So this is JEST Physics 2024 Electromagnetic Theory Part A MCQ 1 marks question. Now it is given that a step index optical fiber has refractive indices N1 is 1.474 for a core region. So this is the core of the optical fiber. N2 is 1.470 for cladding region. So this is cladding region, outer region from the core. And a ray of light is incident from air into the core through the cross section of the optical fiber at an angle theta with normal. So light is incident from air to core. Now you have to find what is the limiting value of theta below which light ray will totally internally reflected. So it means here this angle theta is the maximum acceptance angle. We call this as limiting value is maximum acceptance angle. So it means if incident angle is less than theta, then there will be total internal reflection in core region and light will propagate. But if theta I is greater than theta, then some light will be leaked away. Some light will be leaked in cladding region. That will be leaked in cladding region. So for total internal reflection to take place, theta I must be less than theta. So limiting value is theta I is equal to theta A. This will be the limiting value. And this is given by sine inverse under root n1 square minus n2 square. And this value will be given by sine inverse under root 1.474 whole square minus 1.470 whole square whole under root. And if we calculate this value, this is given by sine inverse under root 0.0 0.0118, and this value is sine inverse 0.1085, and this value is approximately, in degree if you calculate, this will be 6.229 degree. So option D is correct.
So it's a JEST Physics 2024 Electromagnetic Theory Part A MCQ 1 marks question. So in this question it is given that we have to find what is the power of lights emitting photons of wavelength 600 nanometer at the rate 1 photon per second. Planck constant h is given in joule per second and speed of light is c. So we know that power is given by energy per unit time. Power is energy per unit time. So we can write energy as, this is E by T, energy per unit time. E is given by h nu, where nu is the frequency, or we can write this as per unit time is hc by lambda. Nu is c by lambda. So h is 6.6 10 to power minus of 34 into c is 3 into 10 to power 8 meter per second, divided by, let's take it per second, and lambda is given as 600 into 10 to power minus 9 meter. And if we solve it, this value is 3.3 into 10 to power minus 19 joule per second, or this much watt. So option B is correct. So this is JEST Physics 2024 Electromagnetic Theory Part A MCQ 1 marks question. In this question it is given that 3 equal charges plus q are placed at the corners of an equilateral triangle. Now a test charge constrained to move on the plane of a triangle is placed at the center of the triangle. Now which of the following statement about the test charge is true? So we have to see the equilibrium. Stability of the equilibrium depends on which condition. So it is given that we have an equilateral triangle. So let's consider an equilateral triangle. This is an equilateral triangle, and its center is given by, there are plus q charges at each corner, and center is given by, if we connect the vertex with the midpoint of the front line. So this we have to connect in each case. So this is the center of the equilateral triangle, and here we have placed the test charge QT. And let's first assume this test charge is positive. I am assuming test charge is positive. Now for equilibrium condition, the net force on any charge must be 0. The net force F net is 0 on any charge Q. This is the equilibrium condition. Net force on any charge q must be 0. So let's check on this particular charge what will be the net force. So if we consider these two charges, so direction of force will be given by this direction, and let's assume this force's magnitude of force will be F, and their resultant force will be along this line. So let's see the resultant of these two forces F1. I am taking it as F1. And now if you consider if test charge is positive, so what will happen? This force will be also in this direction. So in this condition, net force will never be 0. F net will never be 0. So there will be no equilibrium condition. But if we assume that, again consider an equilateral triangle, and let's assume this is the center of the triangle. On this charge is plus q, this is plus q, this is also plus q. Now I am assuming test charge qt to be negative. Again I am assuming, let's see what will be force on this. So due to this, force will be in this direction, due to this, force will be in this direction. This is the force, and their resultant will be along this line. Let's say this will be F1. But if we consider negative charge, so force on plus q charge will be in this direction. This is force due to test charge. So now we can equate under this condition. When F1 is equal to F2, we will get net force will be 0. So it means equilibrium is possible only when test charge is negative. So it depends on the sign of the test charge. So that's why option A is correct, that stability of the equilibrium depends on the sign of the test charge. Option A is correct. So this is JEST Physics 2024 Electromagnetic Theory question of part B, and it is of MCQ 3 marks question. Now in this question it is given that an infinitely long cylinder of radius r has uniform volume charge density, and a spherical region of radius r is carved out of it as shown in this figure. At what value of r, where r is the radial coordinate in cylindrical system with origin at the center of a sphere, is the electric field maximum? We have to see point P where electric field is maximum. So 4 options are given. Now it is given that it has uniform charge density. So let's assume its radius is, I am taking this as the center, and let's take this radius is capital R, and it is given. Assume this charge density is rho, and rho is constant because it is distributed uniformly. Now to get a cavity like situation, because this portion has been removed, we will assume that we have embedded a minus charge density, minus rho charge density of a sphere of radius capital R, so that it has cavity like situation. Now at point P, the electric field will be by applying the superposition theorem. So at point P, we will first calculate the electric field due to uniformly charged cylinder, and then having charge density rho, and then due to uniformly charged sphere having charge density minus rho. So let's take for r greater than r, if we have infinitely long cylinder, so in this case electric field E1 is given by, you can easily derive this using Gauss law, but you have to remember the result. This is rho r square by twice epsilon naught r cap. This is the field due to infinitely long cylinder. Now we will also find due to sphere at same point having charge density rho. So electric field E2 will be given by minus of rho r cube by 3 epsilon naught r square r cap. So now the resultant field due to superposition is given by E is E1 plus E2. We have to take vector sum. So that will be given by, if we take first term as rho r square by 2 epsilon naught r cap minus rho r cube by 3 epsilon naught r square r cap, and this we can write as, if we take rho r square by epsilon naught common, so this will be, we can write this as 1 by r minus of r by 3, so this will be 3 r square, and on this side you have 2 term also, this will be r cap. So we can write the magnitude of the field, that is mod of E, as, just write down the magnitude. So this is rho r square by epsilon naught 1 by 2r minus of r by 3r square. Now for maxima or minima of E, we will write dE by dr should be 0. So this will be given by rho r square by epsilon naught, and this is minus 1 by 2 r square, and this will be plus 2 by 3 r by r cube is equal to 0, and this will give you 1 by 2 r square, and that will be 2 by 3 r by r cube. So if we solve this, we will get r is equal to, this value is 4 by 3 r. Now we will check whether at this point electric field will be maxima or minima. So let's check it. So we will calculate the second derivative. So let's find d2e dr2. Take the second derivative. So that will be given by rho r square by epsilon naught, and this will be 1 by r cube minus 2r by r power 4. And we can write this as rho r square by epsilon naught 1 by r cube, let's take common. So this is 1 minus 2 r by r. And now we have to check this value at R is equal to 4 by 3R. So this will give you E by dr2. So this is rho r square by epsilon naught, and 1 by r cube will give you 27 by 64 r cube, and 1 minus, and from this equation we can write this 2r by small r is 3 by 2. So we can write this as 1 minus 3 by 2. So that will be minus 1 by 2. So this becomes minus 1 by 2 rho r square by epsilon naught 27 by 64 r cube. So overall this value is negative. So at r is equal to 4 by 3r, E is maximum. E is maximum. So now from the given option we can check that option D is correct. So this is JEST Physics 2024 Electromagnetic Theory Part C, numerical answer type 3 marks question. And in this question it is given that a semi-infinite thin wire extending from minus infinity to 0 along z axis carries a constant current I in positive z direction. The wire is charge neutral except at z is equal to 0, where the inflowing charge is accumulated. Now we have to find what is the absolute value of the line integral. What will be this value? Along the circle, x square plus y square is equal to 1, where B is the magnetic field, mu naught is permeability in free space, and assume that accumulated charge at z is equal to 0 is a point charge. So we will consider a semi-infinite wire along z axis which extends from minus infinity to point z is equal to 0, and here we are assuming that current that is flowing in a wire is I and charge is accumulated at this point. So let us consider, because we know magnetic field due to semi-infinite wire at this end, and so we will consider a circle of radius small r, where r is equal to 1. This r will be 1 because it is given that circle is x square plus y square is equal to 1. So at this point magnetic field B is given by mu naught I by 4 pi r phi cap. This is the magnetic field at one end of a semi-infinite wire. So if we have to find, so let's see what will be closed B dot dl. So at this point magnetic field due to current only, and there will be no magnetic field due to accumulated charge. We will get only magnetic field. So now if we calculate this value, B is given by mu naught I by 4 pi r, and direction will be phi cap. dl is given by r d phi cap, where phi varies from 0 to 2 pi. So this will give you mu naught I by 4 pi r, and d phi will give you 2 pi. So this will cancel out. So this is mu naught I by 2. Now from this equation we can write 2 by mu naught I closed B dot dl. This should be 1. But here we have to find 4 by this value. So this becomes 4 by mu naught I closed B dot dl. We are calculating the line integral. This value is 2. So we will write this numerical value is 2 here. So this is JEST Physics 2024 Electromagnetic Theory Part C numerical answer type 3 marks question. And in this question it is given that magnetic vector potential is given by A, and we have to find the corresponding outgoing magnetic flux through the 5 faces excluding the shaded one of a unit cube with one corner at the origin as shown in figure. So this corner is origin. So let's assume this shaded surface is S1 and for this surface Z is equal to 0. So we know that flux through closed surface is given by closed B dot D. This is the flux through a closed surface and this is always 0. Flux through any closed surface is 0, and we can write this as, let's write flux through surface 1 B dot dA, because it consists of surface S1 and plus rest 5 surface. So I am writing other surface as rest surface where we have to calculate the flux. So this will be B dot dA. This is 0. So this will be given by B dot dA through rest surface and this will be of minus of B dot dA through the shaded region. Now in terms of vector potential, B can be written as del cross A. So let's write it as del cross A dot D. So if we can find this value, we will get the flux through rest of the surface, that is other 5 surface. So let us first calculate curl of A because vector potential is given. So curl of A is given by, we know how to calculate curl in Cartesian coordinate. So this is I cap, J cap, and this is K cap. You have deba X, deba Y, and deba Z. I cap component is 6 here. This is YZ square, and this will be 3Y plus Z. So if we expand, this I cap component will be given by 3 minus 2YZ minus J cap component is given by 0 minus 0. We can easily expand this, and K cap component is also given by 0 minus 0. So this becomes I cap 3 minus 2YZ, and this will be simply 3I cap since we are taking Z is equal to 0 for this surface S1. So this is, we have calculated del cross A. Now for surface S1, what will be dA? So this is the direction of dA, and this direction is minus of K cap. This is area element dA. So dA we can write as minus of dx dy K cap. and then we will get del cross A dot dA at z is equal to 0 surfaces 3I cap dot minus of dx dy k cap, and this will be 0. So del cross A dot dA, if we calculate this value, this will be 0. So answer is 0. Numerical value will be 0.